Good day, students. Welcome to part 5 of the Algebra 2 Trig Regents review for January 2013. On this review series, I'm going to be going over questions 21 to 25. Alright, let's go ahead and take a look at question number 21. It says, this quantities P and Q vary inversely. If P is 20 and Q is if P is 20 when Q is negative 2 and P is X when Q is negative 2X plus 2, then X equals what? So what do we know about two quantities varying inversely? Well, there are a couple of equations we can write for 21. In word form, you say P varies inversely with Q. Basically, P varies with 1 over Q. This is inverse variation. If you introduce a constant, let's say a constant K, then we have P is equal to K over Q, okay, for some constant K. All right, what can we do here? We can do some algebraic processes on this equation to get another form of this equation. If we multiply both sides by Q, we can write this as PQ equals K. All right, so what does this tell us? It tells us that if two quantities vary inversely, then their product is always going to be a constant. It's always going to be the same number. All right, so what is that number? So we can look for a K in this situation by making use of the first piece of information we have. P is 20 and Q is negative 2. So in this case, we're trying to find K, okay? We want to find a K that makes our inverse variation formula to hold. So we're going to put in 20 times Q, which is negative 2, equals K. So what is that constant that makes this product always the same? So if we multiply these two, we're going to have K equals 40. Actually, negative 40. Okay? Alright, now this is the first relationship. Now, if we use this P equals X and Q equals negative 2X plus 2, what equation are we going to get? Well, we can do that here. We know that PQ is equal to K, and then since K is negative 40, that implies that PQ is always going to be equal to negative 40, okay? So if P is X and Q is negative 2X plus 2, what can we form? What kind of equation can we form? Well, let's plug it into this equation right here. We're going to have X times negative 2X plus 2 equals negative 40, all right? If we solve this equation for X, then that will tell us what X equals, okay? All right, so let's do that. So to do this, notice we've changed the inverse variation problem to a quadratic equation. So we just distribute X to these two terms here. So we're going to have negative 2X squared plus 2X equals negative 40. Now I like to factor these by grouping, but before we do that, we have to put this in standard form. So add 40 to both sides to have negative 2X squared plus 2X plus 40 equals 0. Okay, because if I add 40 here and add 40 here, this cancels out and you have that, all right? So notice that I can divide everything by negative 2. So if I divide every single term by negative 2, so this by negative 2, because I like this to be positive, negative 2, negative 2, negative 2. That gives me the equation x squared minus x minus 20 equals 0. Okay, so let's factor this and then use the zero product property to finish it up. AC is negative 20, B is negative 1. What two numbers multiply to give you negative 20 and add to give you negative 1? We can use negative 5 and 4. Alright, so plug that back in here. We'll have x squared minus 5x plus 4x minus 20 equals 0. Alright, so let's break it down to center and factor by grouping. From the first two, I can factor out an x. I have x minus 5. From the second two, I can take out a positive 4, and I have x minus 5 left. Okay, now factor out the two common terms, x minus 5 and x minus 5. So we'll have x minus 5, and we're left with x plus 4. Okay, so times x plus 4 equals 0. Now we're going to use the zero product property to finish this up. Basically, we'll set both results to 0. X minus 5 equals 0, and x plus 4 equals 0. If I solve this for x, I'll have x equals 5. And solve this for x, I'll have x equals negative 4. So the value of x is basically negative 4 and 5. So we can see that our answer is option number 1. Okay, let's take a look at number 2. I'm sorry, 22. It says, between 0 and 360, what is the solution set of the equation negative 2 secant x equals 2? So we have negative root 2 secant x equals 2. So let's isolate the secant. So to do that, we divide both sides by negative root 2 and negative root 2. So we have secant x equals negative 2 over root 2. Okay? How about, I know how to find my sine and cosine. How do I transform this to one of those? Well, if you reciprocate this, we get cosine, right? So if I reciprocate this, I'm going to have cosine x equals, and I reciprocate that also, negative root 2 over 2. Okay? Now let's get what the reference angle is. Then we use the sign here to figure out what the angles are. So to get a reference angle, what I'll do is I'll take the inverse cosine of both sides. Okay, so the inverse cosine of cosine x equals the inverse cosine of negative root 2 over 2. Remember, I'm just focusing on the reference angle. Then I'm going to use this negativity to resolve it. All right, so I'm going to have x equals, now what's the inverse cosine of root 2 over 2? If you remember your special triangles, this is for root 2 over 2 is basically 45 degrees. Okay, so that's the reference angle. Now where do we graph this reference angle? We're told that we're between 0 and 360, so we can draw our 4 coordinate, our axis, and then we have the angles 0, 270, 180, 90, and this is 360 also. Okay, so we have 4 possible reference angles, but when cosine is negative, as you can see right here, cosine is negative. There are only 2 quadrants where cosine is negative. All right, where are they? Well, we know that all students take calculus. That tells me that cosine is going to be negative where you have the S for sine and cosecant and T for tan and cotangent. In these 2 quadrants, cosine is positive. Okay, so what I'll do is I'll draw my angle. There goes my first angle, and there goes my second angle. Okay, our reference angle, this angle I just found right here, this x value is our reference. I'm going to call it theta reference. It's a reference angle. So that means this angle is going to be 45 degrees for theta 1, and then this right here is also going to be 45 degrees. All right, so what are these angular measures going to be? Well, let's go ahead and find what they are. So I'm going to theta 1. The first one is going to be, we're going to start from 180 degrees and we're going to rotate clockwise 145. So it means we're going to go 180 minus 45 degrees. Okay, because we're backing up towards 0. If you make this subtraction, the answer is going to be 135 degrees for the first angle that satisfies this requirement. And the second angle, theta 2. So this is theta 1. This is this angle right here, from here to here, is theta 1. Okay? Alright, so for theta 2, we're starting from 180 and we're going to add 45. Okay, go clockwise 45 degrees, which means, counterclockwise 45 degrees, which means we'll add 45. Our final answer will be 225 degrees. Alright, so these are the 2 angles that satisfies this condition. So our solution set is going to be 135 and 225. Our answer is option number 3. Alright, so there goes theta 1, and then theta 2 is the second one that goes right there. That's theta 2. Okay, now let's move on. Alright, in question 23, it says the discriminant of a quadratic equation is 24. The roots are, what are the roots? Well, they can be broken down into 4 categories, as you can see over here. Well, how do we know where the discriminant of 24 fits in this situation. All right. So let me go ahead and make a chart to help us identify the right spot for 24. Okay, so for question 23, how do we describe roots? Well, looking at the discriminant, I'm going to call it discriminant. Well, if the discriminant is, it could be positive or greater than or equal to 0. Okay, so let's make a branch here. Break down the line. First break happens with a sign. If it is less than 0, guess what we have? We have an imaginary, we have two imaginary solutions. Imaginary. The roots are going to be imaginary. Okay? But if it is greater than or equal to 0, guess what? The uh, roots are going to be, oh, I just messed this up. The roots are going to be real. Okay? So it's either real or imaginary. Okay? So if it's greater than or equal to 0, it's real. Okay, now, what do you have when you have your real roots? What's the situation there? Well, let's see. Well, all we can do is look at the sign, further classification with the sign. Remember, this is greater than or equal to 0. If the discriminant is equal to 0, if it is equal to 0, guess what? You're going to have, the roots are going to be equal. Okay, they're going to be equal, and yeah, they're basically going to be equal and rational. Okay, because the square root component is not there, so they're going to be equal and rational. Now, if it's greater than 0, it's greater than 0, they're going to be unequal. All right. When it's equal to 0, you have a situation called the double root where you have two identical roots, okay? They're going to be identical and they're also going to be rational. All right, but if it's greater than 0, you're going to have a square root piece there. So in that case, they're going to be, the discriminant is going to be unequal, all right? So how can we further classify this? Well, we can classify them using the nature of the number that we have there. Okay, we're going to break it further into two categories. All right, so it just has to do with the nature of the number. If they're greater than 0, they're going to be unequal. If it's a perfect square, I'm going to call it p square. If it's a perfect square, guess what? If it's a perfect square, then they're going to be rational. Okay, because that square root gets simplified into a number that has no radical. But if it's an imperfect square, then they're going to be irrational. Okay, so there goes your classification. Remember, the discriminant is b squared minus 4ac. It's the stuff you have under the square root in the quadratic formula. All right, so this is how you basically break it down. All right, so let's take a look at the number. Let's take a look at the number 24. What do you know about 24 using this continuum that we have right here? 24 is not negative. It is greater than or equal to 0, so we go to the right. So we know it's real for sure, so we can take up option 1. We know it's real. So is it 0? No, it's not 0. So since it's not 0, we know we don't have a double root right here. Okay? So it cannot be equal. So we know that it's unequal. Alright? We have two unequal roots. Now to determine if they're rational or irrational, let me show you. Right now we're going in, this was wrong, right? So we go in this direction, it came down here, we found out it's positive, now we're going here. Now the question is, are we going left or right? So let's look at 24. Is 24 a perfect square? Absolutely not. It's between two perfect squares. 4 squared is 16 and 5 squared is 25. This is an imperfect square, so guess what? We're going to go down to the left side and boom, that's where you have it. Okay, so what do we know about this discriminant? It tells us that the roots are going to be real, unequal, and irrational. Okay? So the roots are going to be real because it's greater than or equal to 0, unequal because it's not 0, and irrational because 24 is not a perfect square. So that's basically how you just go down the branches to classify irrational numbers. Had it been this number where 144, for example, guess what? We'll take the left branch to rational because it's a perfect square. Okay? So there you have it. All right, let me just show you another way to look at this chart. If this chart looks too messy to you, if the discriminant is negative, what does that tell you? It tells you that the roots, you're going to have two imaginary roots. If the discriminant is equal to 0, you're going to have two identical, or you can say two rational and equal roots. Okay? If the discriminant is equal, I'm sorry, is greater than 0, is positive. Yeah, it's positive. Okay. If it is positive, or let's say strictly greater than 0, then, and greater than 0 and perfect square. If it's a perfect square, it's going to be two rational and unequal. Two rational, unequal, and real. Okay? But if the discriminant is greater than 0 and an imperfect square, imperfect, we'll have the case that we just had right now, which is that they're going to be two unequal, because it's greater than 0. They're going to be real, and they're going to be irrational. Irrational. Okay? All right, so that's basically what you have. Okay, let's move on to the next question. In problem 24, we're asked how many different ways can the word tattoo um, be arranged. This is a problem involving alphabetical permutation. So there's a formula for that. You have r squared over r factorial over p factorial, q factorial, s factorial. So it goes on and on. So basically you have the total on the top, the total factorial, and then guess what? All the repeats go on the bottom. The bottom is the repeats. And then over the repeats factorial. Okay? Total factorial over the repeats factorial. What on earth does that mean? Well, let me tell you what that means. So let me rewrite this tattoo up, going sideways. So we have tattoo, tattoo. When I say total, I mean how many letters are there? 1, 2, 3, 4, 5, 6, right? We have 3 T's. 1, 2, 3. We have 1 A and 2 O's. 2 plus 1, 3 plus 3, 6. So we have 6 in total. Okay? So the arrangements are going to be 6 factorial on the top. Now the repeats are what count because if you take the factorial of 1, you get 1. Okay? So that doesn't make any difference to the resulting result. So the total factorial is 6 factorial. And then on the bottom, what repeats? 3 T's repeat and O's repeat. A does not repeat, so don't bother with it. Okay? So how many T's do we have? We have 3 T's, so that's going to be 3 factorial. Okay? How many O's do we have? We have 2 O's, so that's 2 factorial. Okay? So you can do this with your calculator, but let me show you how to do this by hand. We're going to write this. I'm going to break this down 6 to the biggest factorial expression, which is 3. So 6 times 5 times 4 times 3 factorial stuff divided by 3 factorial. And then 2, I'm going to write as 2 times 1. Okay? All right, let's simplify this further. 3 factorial goes here 1, 3 factorial goes here 1, 2 goes here 1, 2 goes here twice. And then we have 6 times 5, which is 30, times 2, which is 60. Bam. There you go. All right. All right, so for those of us that don't know how to do this by hand, we can always use a calculator since you're allowed to use a calculator in the exam. The factorial can be found In the catalog, you can find everything in the catalog. There's another way to find it too, but let's just use the catalog um, menu to access where that is. Okay, so we want to enter 6 factorial, 6, and then I'm going to go second function 0 to the catalog, and then scroll up until I find the factorial notation. Where are you? Okay, right next to the z. So enter 6 factorial divided by, now you notice we have two numbers in the denominator, so we must group them in parentheses. So please, anytime you have multiple terms in a denominator, you have to group them or else you have a grouping error, okay? All right, go back to catalog. So 3, I need to insert the factorial operation there. So go back to the catalog. Let's go to z, because it looks like it's closer to z. Where is z at? X, Y, Z. Okay, oh gosh, that doesn't work. And then go down. Okay, there you have it. 3 factorial and then 2 factorial. Go back to your catalog, scroll up, or you can go to Z and scroll down, same thing. And then you have your factorial. Done. Enter, close that, and final answer is 60. Okay, that's how you do it with a calculator, and I showed you how to do it by hand, whichever method you like. Okay, so you just need to remember this formula for alphabetical permutation, which is the total factorial over the repeats factorial in the denominator. All right. Okay, now let's take a look at question number 25. It says expressed in simplest form. What is 3y over 2y minus 6 plus 9 over 6 minus 2y. Okay. All right, so notice the denominators are different, but they're somewhat similar. One is the opposite of the other, right? So, and then you notice that the differences. We know multiplication and addition commutes, but division and subtraction does not commute. So if I want to make a commutation here, commute any of these two terms, switch them around, I'll have to switch this sign. Okay, factoring out a negative can cause this to be, I can apply a commutative property here. Okay, all right, so we have 3y over 2y minus 6. So I'm going to apply a commutative property here, 2y minus 6. Anytime you switch the order of a negative, you take the opposite, because this term commutes with its opposite. All right, so whenever you commute a negative, you switch the order, a minus has to be factored out of it. Okay, because when I distribute this minus back here, this makes this a minus, and that makes this a plus, which is the same as what we have here. All right, but if this were a plus, the commutative property holds, and I don't have to alter the sign. Okay, it's only because we have a minus in between, that's why I have to do this. All right, so just to help you understand what I just did, 3 plus 4 equals 7, yes, and 4 plus 3 equals 7. That shows you that addition commutes. The order doesn't matter, but when you're subtracting, 3 minus 4 is negative 1, and 4 minus 3 is 1. Two different numbers, so you see that order matters when you're subtracting. Okay, but whenever you want to switch the order, you have to include a negative sign to compensate for that switch. So that's why I have this minus here. Okay, so addition commutes, subtraction, if you commute that, you have to introduce a minus. Okay, now the denominators are the same, so let's go ahead and write it as 1. 2y minus 6. Combine the denominators, and the numerator will have 3y minus 9. Okay, now let's see. Can I factor out anything from the top and the bottom? Or bottom. Okay, so on the top, it looks like I can take out a 3. So I factor out a 3. And then I will be left with y minus 3. And then in the denominator, I'll factor out a 2. Take out a 2. And I'm left with y minus 3. Okay, and then see here, the y minus 3's cancel out, and the final answer is 3 over 2. Okay, so our answer for number 25 is option number 3. All right, so there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here so you can get updates to the upcoming installments of this review series. Um, and please post a comment to let me know what you think. More clips can be found on myserve.com. Thanks again, and have a wonderful day.